Hello YouTube, it's Joe from Calcium Reactor Resource Group here again. I wanted to take an opportunity here to do a video on the reactor that I've currently been using and I'm really having a love affair with here. I've been using it for probably the past 6 months, long enough to know the ins and outs and develop an opinion based on some substance here. And today I'm doing a little maintenance, and I figured it'd be a good opportunity to share that video with you. Right now I'm just using, it's actually filtered tap water, carbon filtered, like my standard whole house filtration system, to do like a rinse on the media. One of the things that really is pretty trick about this reactor that I'm in love with is the waste valve down here, I guess you'd call it. You see I'm just this little airflow in there. Stop that vacuum. I've rinsed the media, and that valve allows you to just dump out. You can basically rinse your media right inside the reactor. So I filled it up with a bunch of fresh aragonite, and I am using some ARM media. I know that's not everybody's favorite. It's the most readily available, so there's a part of me that wants to, instead of fighting to find the perfect media, find a reactor that just makes the media work better. Just a good reactor. I haven't had any issues with this thing. It has been rock solid stable, does what it's supposed to all the time. Initially I bought this reactor because it has the capability of running in a saturation style. Any of you have seen my videos before know I was using an ACR. I really fell out of love with the ACR in a hard way. I still wanted to explore the possibility of a saturation style reactor. What I like about those is you don't need a controller necessarily, which is kind of a falsehood. You do need a controller. You just need the proprietary controller that they sell you, unless you do all sorts of hacks. Again, you'll see all those hacks in my other videos. But for the cost of one of those, such as the ACR, which the ACR is by far the least expensive of the automatic type, or the saturation style reactors, and when you really break it down and do the math, it doesn't make a lot of sense. You end up spending as much on an ACR as you would on just getting a traditional style calcium reactor, and then getting a Apex or some sort of outside control unit, as you would on the ACR. It just doesn't, the math doesn't work out. And in my experience, saturation style reactors, they just run at such a low pH. I never had the issues of melting my media, so to speak, like turning it into mush. But I did have the experience of it just decimating the pH of my aquarium. I've never had my aquarium run at a low pH like I did when I was using the ACR. So currently I switched to this guy, like I said, because it had this really simple, actually pretty badass way of controlling the CO2 without using an Apex, but it also, or any sort of controller, but it also gives you the option of pH. So you could essentially put a pH probe in here and then use your Apex or your Milwaukee to run a stop point on the pH. So that's what got me into it. But it also has the ability of being run solely by pH, and that's kind of where I've landed. Is right back at square one. in my personal opinion, it seems like the saturation style reactors maybe would have had their place in the evolution of a calcium reactor actually before running it via pH control. pH control gives you so much more accuracy. It really would be the future in compared to a saturation style reactor. So back to this one, like I said, I got into it because it had that same type of controllability. It also gave you the pH set point, so you could have a stop. But I've ended up just running it like a traditional one, and I have to say, the things that I did not like about traditional ones that kind of pushed me in the direction of the saturation style reactor, I am not having any of those issues. This thing is built like a tank. It just makes sense. It's built out of molded PVC, Schedule 80 PVC, non-proprietary components. I mean, you can fix this thing, work on it, repair it, get parts for it. The pump that they include with it is a CJ ADV 5.5, I think. And those of you who know these pumps know that they are probably the best pump on the market. You know, they are an AC pump, but they use only like 40 watts. They move 1,500 gallons per hour, readily available and incredibly inexpensive. You can go out, you could probably put a DC pump on this if you wanted to, but DC pumps are definitely not the best for reactors. They tend to attract metals, anything that may be in that water, and it will wear down that rotor a lot quicker. Plus you end up with, you know, anybody who's gone the DC route on everything in their aquarium knows you end up with 1 million controllers and 1 million wires to go along with them, and it really becomes a nightmare. So looks like this thing is rinsed out pretty good. I'm going to pause the video here for a second. I'm going to get this all tidied up, start the filling process, and we'll continue the video, kind of show you how this thing works. All right, here we go again. So I've got my little tub here set up to kind of act like my sump. Inside the sump is the pump that this guy came with. It's just a little DC 12-volt pump, and essentially what that's doing is it's got a couple hoses. These hoses are going to the feed line of the reactor, which is really simple. You see the water coming in right down there, and it also has this exit kind of situation here. So the water actually goes to the pump, from the pump to the reactor, and then back to the sump. And it has this little valve, little cheapy valve here, to create some resistance, but not a ton. And what that does is it lets the pressure that the pump may be creating get released inside the reactor. So this reactor runs at really low pressure. So you just put a little back pressure on there. So this is just trickling back into the aquarium, or into the sump, and it'll still continue to fill. So there's just a tiny bit of pressure going into there, letting that sucker fill up, and then the excess pressure goes back into the sump. A really important feature. I think every reactor should have it. Now this little tube in here is the venturi section. So when this pump is, the ADV is running, this is going to create a lot of this is going to create suction actually through this. This line is your feed line for your sump water, your tank water, and it's also your feed line for your CO2. So this little trick setup here, your check valve, your CO2 is going to go in, and it's going to feed into that venturi, get sucked in, run through the media. Any excess media is going to hang out, or excess CO2 is going to hang out up top here and just be recycled. So this thing is just incredibly efficient. I mean, I'll see maybe a tiny bit of CO2 buildup in here, and it quickly just evaporates. I mean, I barely see any CO2 built up in there, so it's really utilizing all that CO2. That's another thing with the ACRs and those type of reactors. You end up having to bleed them, which in my opinion is just total garbage. You chew through CO2 like it's crazy. I know CO2 is not expensive, but it can be a real pain in the butt to go get those things filled. You end up having multiple tanks. The tanks can be big unless you're running something real cool like I am. I'll talk a little bit about that today. So at the moment, what we're doing here is we're just filling this up. I am tightening these rings. It's kind of like a pool filter. It's got these stainless rings here. I mean, this thing will hold some serious pressure, which is awesome, but kind of not important with this thing. Like I said, it just runs really low pressure. Pretty amazing. So tighten this up, make sure we're rocking and rolling here, and pretty soon this thing's going to start to be full of water. You can see that we're almost above the input water. We've got this all tightened up. I'm going to go ahead and pause the video again, let this thing fill up to capacity with quote unquote tank water. Once that's filled up, we're going to get this thing fired up and show you what it can do. All right, so we've got this guy fired up here, filled up for the most part. It just fired up the pump, so you'll notice that it's a little bit noisy. A whole lot of bubbles going through there. That's just the trapped O2 that's in there. Actually, it gives you a good way to see how well that thing is recycling that air. This little Venturi is just pulling all the air that's to the top of this guy here down through this hose and into the aquarium. Our feed pump is still feeding away. Little back pressure line is still dripping any back pressure that may be occurring. And you can see this is the output. It actually comes with this needle valve. They don't sell it to you, which is great. I think that's a little BS when they sell you stuff. Now, I don't use this needle valve personally as a means to regulate the effluent. I use it like you could, definitely. I mean, you can really have some serious control over this thing. It's a good little valve. I use it more as a dual stage regulator, like a CO2 regulator type situation. And I have this, I set it on like an easy kind of drip. And that goes to a Versa, which I'm just really in love with that little pump. You could use a Dose or any order, like a K mower or any sort of peristaltic pump from there. And this will just kind of dial that pressure or that water flow down before it gets to that peristaltic pump and allow you greater control. You can really dial it in nicely, eliminate any sort of back pressure that could confuse things. So right now, again, this thing will quiet down once all this air has kind of worked its way through this thing and it's filled up. In the meantime, I'm going to pause the video again, try to speed up a little bit of that bleeding process so I can get into the showing you the CO2 and how that works. Okay, so I forgot one of the tricks that they showed me for filling this up initially. So I disconnected from the CO2 and water kind of blending situation here and just ran my water right into the Venturi, and I'm letting the air bleed out this top section here. And you can see that water level coming up rapidly. These are all push connect fittings, so it makes it really easy to just disconnect, reconnect. I'm gonna stop this video again. I'm doing this one-handed with the iPhone, so I'm gonna switch this out real quick, show you again how it looks in its working configuration, and we'll go from there. Okay, you can see I've got this reconfigured here. That was real simple to do. Essentially, I unplugged this piece and I plugged my water feed pressure release Y fitting right into here, so it was filling, and I let my air bleed out this little top valve here. Again, we have trapped air in here. This is a restart of the reactor, so once that air is cycled through, this thing will be ghostly silent. You could hear it already starting to slow down. this is really just a good indication of how well this thing sucks the CO2 out of the top here that may get trapped in there. I mean, it's just the most efficient I've ever seen or used. The dome style lid really kind of does a perfect job of letting that CO2 collect at the top and get pulled through. So the path of things here, we've got our feed pump and our pressure release valve. You can see a lot of that extra pressure just kind of coming out of that valve. It just kind of lets it burp back into your sump to prevent this thing from getting pressurized. If it did, not a problem. This thing's a beast. It can handle the pressure, but it's just no good for the process of running a calcium reactor. It doesn't require pressure to work. In fact, that can just make the flow through and all those things really tricky on you. So water goes to this and back to release pressure. And from here, it goes into this feed line. This feed line is a Venturi feed line, so it's constantly being sucked through here into the flow down through the bottom of the media. Now back up to this top part where your water is going in, you have your CO2 feed line. It comes with a check valve, a good check valve, like the good check valve. You can add a second one. I actually run a second one. Don't currently have it on here. I just didn't see the need while I was setting this thing back up. So check valve comes with it, needle valve comes with it. Really good pH probe port. This makes it so easy to take out your probe and calibrate it. That's one of the gripes I've had with pretty much every reactor I've used, is the pH probes are typically really hard to get to and annoying to change out. This is a sweet one. Really, really nice. All of these fittings are easy to adjust, tighten. The pump can easily be replaced. Nothing on here is proprietary. I mean, this thing is, it's like, it's a dream for me. Inevitably with reactors, they're made out of acrylic. Typically, this one's molded PVC. The acrylic gets brittle, parts crack, and either the manufacturer's out of business or they've discontinued that line and you can't repair them. This is molded PVC. It's just not going to get brittle. It's going to last. It's going to be around longer than we want it to. And anything on here that you need to fix could be DIY'd if you really were in a pinch, but all the parts they make it readily available. So I can't say enough awesome stuff about this thing. So CO2. So right now you can hear that it's pretty much ghostly quiet at this point. We still have our pressure release thing kind of dripping back in there. We're going to open this up a little bit just to kind of simulate a slow drip into the tank. Again, I use a Versa. After this, I run it a little bit faster than that into the Versa, let the Versa do the math. I've got my CO2 regulator hooked up. I'm just using my little mini rig here. I really like this thing, saves a lot of space underneath the sump. If you are running a really big tank, you're probably going to want to just run a bigger tank on there. These things only last, on my tank, about a month. I have spares of these little guys. They're just paintball cylinders. And then I have a filling station that I set up in my garage. So basically for the cost of a CO2 tank, you would have had to buy that CO2 tank anyway. I bought a little fill valve. I fill up these little guys in my garage, and then when this runs out after a month, I just replace this and I just keep swapping them out. I have a big 20-gallon tank or cylinder in my garage. That thing would be way too big for under my tank, but it will last me years of just refilling and swapping these things out, and then I save that real estate underneath my tank, which we all know how valuable that is. So we're gonna set this drip. We got this drip going, simulating the effluent going into our aquarium. I'm going to adjust my regulator here, and you're gonna see that CO2 is gonna start blipping in here. There it is. You can see that. We'll run it a little too hot here so you can see that. That's your CO2 just getting mixed in like you've never seen it get mixed in there. I mean, it doesn't get much better than that. Of course, we wouldn't be running it that rich. You could be using your carbon doser. You could use a cheapy regulator. You know, I never think regulators, I mean, there is a line. You get a real crappy regulator, you're gonna have some issues. It's probably not gonna last very long. So I like to use a good regulator, but as far as carbon doser, fancy stainless steel one, I don't think it matters. I think the real important thing is to run 2 good check valves, keep an eye on it, don't let any moisture get into that regulator. You should be good to go. So here we are, this thing is doing everything it's supposed to do. You can see that CO2 starting to create a little CO2 bubble in here, and we will turn this off. Get a little extra CO2 in there, turn that sucker off. So now our CO2 is turned off, and you can see this thing quickly sucks all that CO2 out of the top, leaves a really minimal little bubble here. Any CO2 that collects at the top is just going to get sucked back into this thing. Like any calcium reactor, it looks like it's got a lot of stuff going on. In all honesty, this one is the most simple, robust, quiet. All those tag words we all like to hear, some of them end up being true, some of them don't. This thing nails it. It's built like a tank, works like it's supposed to. I'm sold on this one, folks. Thanks again for watching. Like my video, please subscribe. I could use all the help I could get with this stuff. I'm gonna do some more videos. I have a Corlin coming my way. I want to do some ins and outs on Corlins. You know, a lot of people already have a calcium reactor. I want to touch on some ways to run them a little bit better than they're currently running, set them up correctly, repair them if necessary. I have another ACR that a customer's that I know switched out to one of these at my advice. He's going through the same thing, absolutely blown away by it. I'm going to take that ACR and do some more videos on it, kind of a long-term review on it, why they might make sense for you, mostly why they don't make sense, and kind of hopefully help you make the right decision on what's best for you. Again, thanks for watching. I hope everybody's doing great, and we'll see you soon.